All right, class. Welcome to this video introduction and recap for lesson 10.1.5. This is actually the final lesson in section 1 of chapter 10. So it gives you a chance to use what you've learned about chords and arcs and inscribed angles and central angles to work through some challenging problems here. If I pull up that lesson, sorry about the delay, guys. But if I pull up that lesson, it starts with an optional problem, which is 1050. And that one was made optional just because it was a pretty involved problem that involved a compass. Since we weren't together in class, that's one that if you're looking for more of a challenge, you can do. Knowing that segments AB, BC, and AC are chords inside of a circle connected from the center point of that triangle is enough information to work through that. You just need to know that to find that center point, you're going to need to use the perpendicular bisectors of each of those different line segments. So if you can use those, you should be able to find the center and then to draw that circle that circumscribes it. For the non-optional problems, which are 51, 52, and 53, you'll still be required to think a little bit outside of the box, but you'll be able to use all those things you've been working on with properties of circles and the different things that we've learned in chapter 10. What I'd like you to do right now is work on 51, 52, and 53. Be sure to draw those diagrams on your paper so you can draw on them, add angles, do things to let you work with them easily. And then once you're done working, come back here and we'll go ahead and recap those problems. So right now, go ahead and get started. Good luck, and I'll talk to you in just a little bit. All right, and welcome back. Hopefully you're back here because you successfully completed 51, 52, and 53 and just want to compare your methods with me. But in case you got stuck, let's talk a little bit about how you would approach some of these problems. So the first one in 51, we're given a circular dinner plate that has an 8-inch knife set up as a chord inside of that plate. They also tell us that the minor arc it intercepts is 120 degrees in measure. So that right there lets us set up our own diagram. So I have my plate right here already drawn. If I draw my knife, which may look something like that, then I can work with the fact that I know this arc has a 120 degree measure. Just so we can talk about it, let's put an A and a B on that arc. So arc AB measures 120 degrees. And what that does is it allows me to create a central angle. If I can get my ruler here. So I create a central angle that opens up to that arc, so I know it also has a 120 degree measure. I know our knife was 8 inches, so that was an 8-inch side. I also know, because I've drawn from the center point to each of those points on the outside of the circle, I know those sides are congruent because they're each a radius of that circle. So things are looking really good. Because I've created an isosceles triangle, I know the base angles will be congruent to one another. And if you do the math, you'll see those have to be 30 degrees each. So right now, I can easily find the missing parts of that triangle. Doing that will let me find a radius, and then I can double it to get the diameter, which is what's asked for here. You can use the law of sines. You could divide up into two triangles by drawing a line that is perpendicular to this base. The reason I chose to say perpendicular and not a bisector is because if it's perpendicular, it creates a right angle, a 30 degree, and I can find the other angle. I also know that one side is congruent on each, so I could use angle side angle congruence to know that each of those was 4. So that could prove that it was bisecting that 8-inch dinner knife. then you could use your regular tangent, sine, or cosine. So you have different approaches to find that missing side, whether it's using the law or just regular trig ratios. The trick here was just getting that triangle set up for you. For 52, if we look at 52 quickly, it works with a cylinder, and we know from our work in the previous chapter that for prisms and cylinders, all we were doing was finding the area of a base and multiplying it by the height to get the total volume of that three-dimensional solid. And this problem is no different. The issue is you only have a sector, not an entire circle. So you'll need to realize that finding the full area of the circle, that needs to be multiplied by 1/8 or divided by 8, because 45 degrees is 1/8 of 360. And then you can use that area of the base to find the overall height. Now the final problem, 53, is a really interesting one. Let's take a look at that. So we have two lines, AB and CB, which are tangent to circle D. So let's do that really quickly. All right, so let me see my point names one more time. A, B, and C. All right, so AB is tangent to the circle there. And CB is tangent here. And then the first thing we're asked to do is prove that AB is congruent to CB. That's an interesting problem that will definitely involve drawing some additional lines and some of the properties that you know. So if we add a little bit to our diagram, like connecting AD and CD, we can start getting some work right there. So I know that AD and CD will be congruent because they're each a radius of the circle. I also need to use one other important property, which was that any radius that met a line tangent to a circle would be perpendicular. So I'll draw those right angles. The final thing I can do is draw a line connecting B and D. And by doing that, what I've done is I've set myself up to have two triangles. Triangle ABD and triangle CBD. And those triangles have to be congruent because we have the reflexive property from side DB in each. AD and CD are marked as congruent, so we've got those two sides. And we also have that right angle, which lets us use hypotenuse leg congruence. Since they're congruent, we know congruent parts of congruent triangle, or corresponding parts of congruent triangles are congruent. So BC and BA have to be congruent, and that's what we were setting out to prove. I didn't draw a full formal proof. I'll leave that to you guys to create a two-column or flowchart proof there, but that's the thought process behind that problem. Once you've done that, I think part B should follow a little bit more straightforward. So if you were able to get through this lesson on your own with just me as backup, I think you're in really, really good shape right now with these new circle properties and also with the proofs that we've been working on in the background still. If you struggled a little bit, I don't think it's time to panic, but I think you need to make sure you're watching all my videos and you're really staying on it so that you can really grasp this new content. Please let me know if you have any questions about this lesson. You can always shoot me questions from 9 to 11 during office hours, and I'll get you answers right away. All right, guys, have a great day.